Hello students, so we are going to see the worksheet problems. So let us start. So the first question is a particle having charge 1 coulomb. So charge of the particle is given 1 coulomb is moving in a magnetic field of 0.5 Tesla with a velocity of 10 meter per second, making an angle of 30 degree with the magnetic field. Magnetic force, they are asking to calculate magnetic force experienced by the particle. So let's quickly try to draw the diagram, and we know the formula, magnetic force formula. What is magnetic force? Q V cross B. Q V cross B. So this is a cross product, right? So we need to see whether the charge particle is a positive charge or not. So first of all, charge particle, if it is positive, then force is in the same direction. Anyway, in the question they are asking magnitude, so you need not bother, you can simply calculate the magnitude. So magnitude means what? Magnitude, if I write magnitude Q V B, and angle between velocity and magnetic field, so that means sine theta we have to take, right? So let us substitute the values. So they have given velocity of 10 meter per second, making angle 30 degree with the field. Direct question it is, we need to substitute values. So substitute. So what will be the magnetic force? Charge is given. How much charge is there? 1 coulomb. It is a, whether it's positive or negative, now it doesn't matter because you are calculating the magnitude, right? Direction you are not calculating. So 1 coulomb charge. What is the velocity? 10 meter per second. What is the magnetic field? What is the magnetic field? How much is the magnetic field given? 0.5 Tesla. 0.5 Tesla. Right? And theta is how much? 30 degrees. So sine 30 degrees half. Now you calculate this. So from here, how much can we calculate? So will it come 2.5? Check that. So that is the answer, 2.5 Newton. Because all the values are in SI unit, so force is also SI unit, 2.5 Newton. Clear? Let us move to the next question. If a charged particle enters a uniform magnetic field, a charged particle is entering into a uniform magnetic field, neither perpendicular nor parallel. So it is moving and it is entering into a field, and its velocity is neither parallel nor perpendicular. So what happens if it is parallel? What happens if it is perpendicular? What happens if it is neither of these, right? So you have the basic idea about that. Suppose if a charged particle is there, q, and it is going the velocity v vector, which is parallel to magnetic field, or it can be anti-parallel also, it does not matter, but the force, magnetic force, is going to be 0. Yes. Why magnetic force? Because velocity is making 0 degree with magnetic field, or if velocity makes 180 degree with the field, then also force is 0, right? So that means in this case body will continue in the straight line, this case. And second case, right, second case, if let us say there is a magnetic field, right, magnetic field, and the particle is going to enter into this magnetic field, right, with a velocity v. So assume that charge is positive charge, so v cross b, you have to see v cross b means upward. So this particle will start moving in a circular motion. So this path is circular motion, you know that this is circular, uniform circular motion will happen, and here no change will happen, it will continue straight line. Now they are saying combination of this. For example, this is the third case where a charged particle is thrown like this at an angle of magnetic field. So this is also a standard case. Here we will resolve velocity into two components. One is velocity parallel to the field, one is velocity perpendicular to the field. So this motion is going to be a three-dimensional motion. This motion is not a two-dimensional motion. How it is three-dimensional? Because here, see, this is a straight line, one-dimensional motion, you can say. This is a circle, circular motion is a two-dimensional motion. Now this motion is going to be a three-dimensional motion. Why? Because suppose if there is a velocity along the parallel only, then it will go straight line. And suppose there is a velocity in perpendicular direction only, then it will go in a circle. You know that. And the circular motion is in the plane of the velocity. So here the velocity is in this plane, and this parallel velocity will also make it move. So it is like a circle in this plane, and in this direction also it is moving. So that is what is called helical path, right? So here the path is a helical path. So helical path means it will go like this, then it will go like this, then it will go like this. It is coming out of the plane and going inside. So this is a three-dimensional motion, right? So path is a helical path, it's a helix, and the helical motion is also a uniform helix. The helix is a uniform. Why? Because there is a pitch, there is a equal distance it travels along this direction, along the direction of magnetic field. It travels equal distance in equal time. That means in this direction velocity is constant. Suppose in this direction there is acceleration, might be because you are keeping some electric field, or due to some reason there can be a acceleration in this direction. Then in that case it will be also like a helical path, but that helical path has non-uniform helix, you can say, because the pitch will not be defined there, because in equal time it will be traveling unequal distances due to acceleration, right? Let us move to the next question. Let us read this question, what it is saying. A proton and alpha particle, after being accelerated through same potential difference, we are accelerating through the same potential difference, enter uniform magnetic field, direction of which is perpendicular. Perpendicularly they are entering, so you know what will happen, it will go into circular motion. Fine. Then find the ratio of radius. Radius ratio you have to calculate. So first of all you have to tell radius formula. Radius is equal to mv by qb. mv by qb. mv can be written as momentum p by qb. qb. Momentum can be written in terms of kinetic energy. So let us write momentum in terms of kinetic energy. So this radius can be written as momentum is root under 2 times mass into kinetic energy. Kinetic energy. Okay. And kinetic energy can be written as charge into potential difference. You know that, because the work done is change of kinetic energy, and kinetic energy change, that is like charge into potential difference. So now we will write this as root under 2 times mass charge into potential difference. I am writing as delta V, potential difference, and divided by QB. Now Q can be taken inside, so this formula will little bit now become, radius will become equal to, now it will become root under, if you want everything you can take inside, so root under 2 m, here it will become q square will get cancelled, right? So this is b square and delta v, right? So radius is proportional to what? Here two different charge particles are there, so one is other things are same because they are accelerated, right? Same potential difference, so delta v is constant, so this is proportional to root under mass by charge. Mass by charge, so whichever will have more this ratio, mass by charge, whichever has more, that will have more radius, correct? Now you choose circular path to particle radius. Ratio of radius, they are saying ratio of radius. So suppose if I take, first is which one we should consider first. Let us take proton. So proton, if I take radius of proton, that is proportional to root under mass, and here charge is, let us say, e. And for alpha particle, this is proportional to mass of alpha particle is 4 times mass of proton, so this will become 4m, and charge of alpha particle is 2 times charge of proton, so 2e. So you can clearly now take the ratio and alpha particle. So we have to calculate proton by alpha particle, I think. So let us take ratio of proton by alpha particle. So proton by alpha particle ratio when I take, What do we get? We get 1 is to root 2. 1 is to root 2. Right, 1 is to root 2. We get option C. That is the correct answer. Right, let us move to the next question. Next question. An electron is moving along positive x-axis, right? Okay, a uniform electric field exists towards negative. So electron is moving in this direction, positive x-axis, and electric field exists towards negative y-axis. So electric field is existing in this direction. Electric field is existing. This is the direction of velocity. This is the direction of electric field. What should be the direction of magnetic field of suitable magnitude so that net force on electron is zero? You want that net force to be zero. That means you want that electrons should just continue in the same direction without deflection. This is what is the main thing, that without deflection, condition for no deflection is that net force would be zero. So just try to find out the, anyway they are asking direction, right? So you have to see the direction of electric force and the direction of magnetic force. They must be opposite. So first of all, let us take the direction of electric force. So which direction electric force act? Because uh, charge into electric field, but charge is a negative charge. So negative charge into field direction will be this way. If charge is positive, so it will go in the direction of field. Otherwise, opposite means this direction. So the direction of the magnetic force, electric force direction is upward. That means in the positive y-axis. Definitely, the magnetic field must produce a force in downward direction. So magnetic force must be in this direction. Magnetic force. Now, if this is the velocity, this is the magnetic. So you know that the field, force, and velocity all are in perpendicular directions, right? Because force is q v cross b. So first of all, you try to find v cross b direction. V suppose you take v magnetic field inside only it is possible, it cannot be in the same plane. So magnetic field has to be perpendicular to the plane, either going inside or coming out. Suppose if I take magnetic field is going inside, so v cross b direction is what? V cross b direction is upward. Remember, charge is negative, so it has to be opposite of v cross b, then magnetic force will be downward. So that means our assumption is correct, that magnetic field must be inside, because v cross b is going up and you have to take opposite of that because charge is negative, so downward force, right? So that means you can say that magnetic field must be going inside. Magnetic field inside means cross. Magnetic field must be inside means along negative z direction, right? So negative z axis direction, we can choose option B. Clear? Let us move to the next question. A particle of charge q and velocity v passes undeflected through a space with non-zero electric field E and magnetic field. Under the undeflecting condition will hold it. So undeflecting condition, they are saying undeflecting condition. So we know what is the undeflecting condition. Net force has to be zero. Net force is zero. What is net force? Net force is q v cross b magnetic force plus what? Plus electric force, which is q into E. This is what is the sum of this is called Lorentz force. So this has to be zero. Zero is also a vector here, right? So q you divide it. So that is idea is that v cross b plus E vector has to be zero, right? Sum of this zero means zero vector, you can see. So this is the condition for no deflection. Now here let us check. They are saying the undeflection condition will be true for which? Signs of both charge and E are reversed. See here, charge sign is not because charge is not at all coming in this equation. Charge is not at all coming, so we don't have to bother about charge. Anything about charge we don't have to bother, leave that. So leave this first option. Signs of q, again charge is not important, leave that. Both b and e are changed in magnitude but keeping the product of and fixed. So now we are seeing B and E. So what they are saying that option C, both B and E are changed in magnitude. They are talking about magnitude, but they are not changing the direction, but keeping the product of and fixed. B and D, product of B, it is not depending on product of B and E, right? So this should not be there. What about this? Both B and E are doubled in magnitude. Both B. See here, if you double B and you double E, it doesn't matter because that factor will get divided, right? So in terms of magnitude, you can say they are proportional, right? So magnitude, if you say they are proportional, so we can choose option D, right? The product of means what? So we cannot directly say a relation between B and E. If you change B and E, also need to change by the same factor, right? Both B and E are changing magnitude, but keeping the product, not the product. You can say the ratio has to be kept constant. Why? Because suppose if I take that side, then V cross B become equal to minus C. Now let us take the magnitude of this. Let us take magnitude. Let us take magnitude. So magnitude of V cross B means VB sine theta, and magnitude of E vector means E. So now suppose B, if you change, E you have to change by the same factor, then only this thing has to be constant. Or you can say that this VB sine theta should be constant, then E will remain constant, right? So E other factors if you leave, then B is proportional to E. So whatever factor you are changing E, same factor B also you have to change. You are seeing the relation between B and E, other things are constant. So that means B is proportional to E magnitude wise, or their ratio must be constant, not their products should not be constant, their ratios must be constant, right? So option D is the best choice, right? Let us move next. An electron having kinetic energy T is moving in circular orbit of radius r perpendicular to a uniform magnetic field. Kinetic energy is doubled and magnetic field is triple, the radius will be. So let us write the formula for radius, direct question. Radius radius is mv by qb, we know it is momentum. So kinetic energy T is moving circular, okay. If kinetic, so kinetic energy and magnetic field, radius depends on mv means momentum by qb, momentum let us write in terms of kinetic energy 2 mass into kinetic energy, right, into qb. Now let us see what they say. Kinetic energy is doubled. So if you double the kinetic energy, how radius will change? So radius will change how many times? So if you double, then root under 2 times will come. Root 2 factor will come in numerator, right? And what about the magnetic field? Magnetic field you are triple. So root 2 by 3. Root 2 by 3. Let us check that. Root 2 by 3 times it will become. Radius will become this many times. Root 2 by 3, you check which answer is root 2 by 3. 3 you can bring inside also. So this will become root under 2 by 9. Root under 2 by 9. So option C, that is the correct answer. Right. Let us move to the next question. A deuteron of kinetic energy 50 kilo electron volt is describing a circular orbit of radius this in a plane perpendicular to magnetic field. Okay. So it is going in a circular motion. The kinetic energy of proton that describes a helical path of radius this in the same magnetic field. In the same magnetic field. Okay. Let us try this. So what they are saying that a deuteron is there. Okay, whose energy is some energy is there, 50 kilo electron volt. That means this is the kinetic energy. Kinetic energy is given. Okay. Which describing a circular radius is given perpendicular. So let's write radius formula in terms of kinetic energy. So radius is equal to root under 2 times mass into kinetic energy divided by qb, right? This is the radius. This is the radius formula. Now they are saying relationship of radius. Radius is same. Radius is not changing. They are saying same radius 0.5, 0. So radius is also same. And one is deuteron. Deuteron means it is like a proton only, but charge is same, but it is having mass double than mass of proton. Okay, so deuteron has mass double than mass of proton, and we are keeping now proton, the kinetic energy of proton. So proton, for proton we have to see, right? So this radius formula we are going to, radius is anyway constant, charge of proton and neutron are same, magnetic field is also same. So directly we can say that this product must be constant. So the product of mass and kinetic energy must be constant, right? That means what? That means kinetic energy is inversely proportional to mass. Inversely proportional to mass. So how many times if you are taking proton? Previously it was given deuteron. So deuteron kinetic energy was 50. Now you are taking what? You are taking proton. Proton mass is half of deuteron. So because mass has become half, mass has become half means this factor will become 2 times. So kinetic energy will become 2 times. Kinetic energy will become 2 times. 2 times. So how much kinetic energy previously was there? 50. So 50 will become 2 times 100, it will become 100. It will become 100. So which option you can choose? Less than 25? No. Less than 50? No. Less than 200? Greater than 200? Greater than 200 it is not going to be. Less than 200 it is becoming nearly 100, right? 100. I am assuming the this relationship masses like this. Okay, so we can go with this. So definitely 100 it is going to happen. 100 means which is less than 200, you can go with this option. More than 100 you can cancel out, right? Now here there may be a little bit confusion, like is the mass of proton and neutron exactly 2 times? That means is the neutron exactly 2 times the mass of proton? If it is exactly, then our calculations are correct. Okay, but definitely it will be less than 200. Definitely it will be less than 200. But suppose actually this data if you have, then you can compare, you may get exactly, it may not come exactly to, but it will come near to 2. Exact value in atomic mass unit you can check, but I think we can take it double for most of the calculations, right? So let us move to the next question. Three ions are given. Okay, same kinetic energy pass through a region in which there is uniform magnetic field perpendicular against circular motion, least deflected. This will be deflected equally. Deflected equally means radius you have to consider. Radius here. Suppose some charge particle going this radius, some is going large radius. So how much it is bending or how much it is deflection is happening. So radius is what they are asking for, right? So radius, let us try to compare radius. Radius calculation, let us do radius. So radius is what? Here we have to bring in terms of what? Kinetic energy. Again, this formula again coming. Root under 2 times mass of into kinetic energy by QB. So kinetic energy is same. Mass and charge are only, going to be different. Mass and charge are only going to be different. So now you need to consider which will have least, which will have like radius you have to compare. So radius is proportional to root of mass by charge. So let us take for example H plus. Hydrogen plus means it has lost its electron, so it is like a proton. So proton it is. So first case proton H plus. In H plus, what is the radius? Radius is proportional to mass. Let us write mass of proton as m. Charge is E. Then what about helium plus? Helium plus radius is proportional to mass of helium. Helium mass is 4 times, right? So 4 times will come here inside 4m. And what about the charge? Charge is helium plus means what? Helium plus means what? What is the charge? What is the charge? Charge means it has lost one electron, right? So it develops one extra proton. That means charge is going to be same only. Charge is going to be same only. Note that. Helium plus it is not helium plus 2, right? Oxygen plus 2. Oxygen plus 2 means what? Again, try to calculate. Suppose I write oxygen plus 2. So this radius is proportional to. Now, let us write. How much will be the mass of oxygen? One oxygen, 16 we can take, so it is like 16 m, 16 m. And what is the charge? Plus 2 means 2 electronic charge will be there. 2 electronic charge will be there. Okay. So now try to check it. So if you see here, 2 square inside will become 4 and 16 by 4 will give 4. So this is also going to give us root under 4m by e. So that means these two radiuses are equal. These two radiuses are equal. Correct? These two radiuses are equal and definitely it is larger than hydrogen plus. Now you can choose. Hydrogen plus will be least deflected, yes, because it is the smallest. So, right? Helium plus and oxygen plus 2 will be deflected equally. Yes, deflection. Now here radius we are calculating. So is the deflection depends on radius or not? How do we know that? Deflection, how do we calculate deflection? Hmm? Deflection, how? Deflection means is it the radius only or is it something else? We need to think about it, right? But in case of electric field, definitely it is not. But if there is a magnetic field also, so can we consider the deflection? For example, suppose you are sending different particles. All these are positive, right? So suppose they are going like this way. So they may have different radius. So smallest radius will go like this, right? Larger radius. So I think the radius we can consider as deflection. So this question will have then two answers. Hydrogen plus will be least deflected, right? Least deflected. This is correct. Helium plus and O plus 2 will deflect equally. Yes, because they have same radius. Oxygen plus 2 will be deflected most. So we cannot say because oxygen and helium will be same. All will no. So we can go for two options here. Two answers will be there, right? Let us move to the next. Electrons moving with different speed enter a uniform magnetic field in direction perpendicular to the field. They will move along circular path. Electrons moving with different speed enter. So their speeds are different and they are going to move in a circular path of same radius with different time period. Okay, so radius, electrons with different speeds. So radius is equal to mv by qb. So electrons have different speed. So other things are same, mass and charge is same, magnetic field is also same. So radius is proportional to speed. So more the speed, more the radius. Of same radius is not possible because speed are different. Okay, with larger radius for faster electron. Faster electron means larger speed, larger radius, but will have same time. Time period formula we need to check. Time period formula is 2 pi m by qb. So time period does not depend on speed. So time period should remain same. For all electrons, time period should remain same. So that means time period will remain same. So we can go for option B. With the smaller radius, smaller no time period will not change. Fine, that is the answer, right? Let us move to the next. A particle of mass m and charge q moves with a constant velocity v along the positive x direction. It enters a region containing uniform magnetic field directed along the negative z direction, extending from 0 to v. Minimum value of v required so that the particle can just enter the region. So let us try to understand this question, what they are saying. So particle is there, charge and mass is given. It is going along positive x direction. So this charge particle is going this charged particle Q and M is moving along positive x-axis, right? Which direction field is existing? Field is existing directed along negative, means inside. Field is inside. Okay, so let us take field as cross like this. Magnetic field is cross inside. Then what they are saying that, and they are saying magnetic field is extending from x equal. Okay, so magnetic field is not present everywhere. Magnetic field is limited. So up to how much distance it is limited? How much distance it is limited? So let us say it has entered here. You can take, let us say that it has entered here. X is equal to how much? X is equal to A to X is equal to B. Minimum value of speed required so that particle can just enter the region X greater than B. So let us say that this is A and this is X is equal to B. Particle has to go that side. Suppose if this speed is like this, right, and it is going in a circular motion, means circular motion will not be complete. At least here it can get, if you give more speed, then it will go like this. So if it is able to take a turn here, then it cannot go that side. That it cannot go. So extreme case, if you take that, if this is the radius, let us consider if this is the radius, then it will take a circular turn. So this distance, which is nothing but this is A, right? So this distance is B minus A. B minus A. So if this distance B minus A is equal to radius, or if this distance is greater than radius, then it will never be able to enter into that, right? So B minus A, if it is equal to radius, or if it is greater than radius, then it can never go. So it must be less than radius. That is the condition. Radius formula is mv by qb. Let us apply that. So v must be greater than qb by m b minus a. That should be the condition. Let us check that. Greater than should be equality, you can say, because just enters means equality you can apply. So what will be that? qb by m, qb by m b minus a, qb by m b minus, this option, right? Second option we can go for, right? Let us move to the next problem. A particular charge q and mass m starts moving from origin under the action of electric field. So electric field is also along x-axis, magnetic field is also along x-axis, velocity is along y-axis. The speed of the particle will become 2v naught after a time. So after time, its speed will become double. Speed become double. So note that the magnetic field is acting in the same direction, right? So note that electric field and magnetic field are in same direction. Electric field and magnetic field are in same direction, correct? Same direction. Both are along x-axis. Now, velocity is which direction? Velocity is this direction. So charged particle is going in this direction, right? So now note that the magnetic field will try to move in a circle, and what will be the radius of that, or which direction force will be coming? V cross B direction you do inside, so it will try to go in this plane. This will be the plane of this circle. But electric field is acting in this direction, so electric field will only change the speed. Electric field will only change the speed. Okay, and they are saying that it will become 2v naught. 2v naught. So in this direction there is acceleration, and there is acceleration which is a centripetal acceleration due to magnetic force, right? So you can apply work energy theorem, best approach. Work energy theorem apply. So work done, net work done is change of kinetic energy. Kinetic energy is half m Final velocity square minus initial. Final velocity is 2 v naught. So 2 v naught square means 4 v naught square minus v naught square. So how much you get from here? You get 3 by 2. 3 by 2 mv naught square. This is the change of kinetic energy, and work is done only due to electric field. Electric field is a constant. Electric field is a constant, and the body may be moving in any direction. Electric field is a constant, so in that direction acceleration is there. So force into displacement we can take in that direction. So force, what should we write? Force is QE by m. Q into each force, right? This is force. Force into displacement. Displacement is, let us say, delta x. This displacement you can write as ut plus half at square. Let us try that. So if I write that displacement as ut plus half at square, u is anyway 0. So half acceleration is again this force by mass, right? Force by mass, half a t square, time square. This is equal to 3 by 2 mv naught square. Now from here time we can calculate. So let us calculate what is the time from this equation. Time will be equal to what? This 2 will get cancelled, right? So time m square v naught square. So m v naught will definitely come because it is under root. E square will also will give QE will go, right? And that 3 which is remaining, that will keep us under root, right? So root under 3 m v naught. Electric field is E naught, so we can take this E naught, right? This is the answer. Root 3 m v naught by q E naught, option D. That's the answer. Fine. So I hope you got this. Very basic kinematics it is. Let us move to the next question. Electron is projected with velocity v naught in a uniform electric field perpendicular to the field. Again, it is projected with velocity v naught perpendicular to uniform magnetic field. If R1 is initial radius of curvature just after entering in electric field and R2 is initial radius just after magnetic field, then the ratio R1 to R2. Radius of curvature is nothing but we can calculate just like for magnetic field we know that radius of curvature. For magnetic field, what is radius of curvature? R2 here in this case mv by qb, right? Some velocity is there v naught, okay? Velocity is v naught. It's a electron, so charge you can write as C. Perpendicular. So electric field is also perpendicular. So we are projecting perpendicular to electric field. For example, suppose electric field is like this, okay, and you are projecting this charge particle in this direction with v naught. So this force which is acting here in this direction, that will give like centripetal force. So in this case also you can derive this formula that QE will act as a centripetal force as mv naught square by radius. So this radius which will calculate R1, it will be mv naught square by QE, right? Now let us take the ratio R1 R2. They're asking what? Ratio R1 R2. So take ratios R1 to R2. So m v naught square by QE by m v naught by QB. So m v naught cancel, Q cancel. What do you get? What do you get? From here B by E definitely comes out, and one v naught remains here. So v naught B by E. Let us check that. V naught B by E. This option number D, right? So I hope you got this simple question. Then let us move to the next. Two identical charged particles enter uniform magnetic field with same speed but at angles 30 degrees, 60 degrees with field. Let A, B, C be the ratio of the time periods and pitches of helical path. Which of the following relation is correct? So first of all, ratio of time period. Time period depends on what? Time period first of all is 2 pi m by qb. Time period is independent of speed, so time period must be same for each one. Time period must be same. A, B, C are the ratios of the time period. So ratios of the time periods, right? A, B, C be the ratio of their time periods. Um, Time periods, radii, and okay, they are separate. So A is the ratio of the time period. So A is going to be uh, A is going to be 1 only, because A, B, C are ratio of their time periods, radii and pitches. So definitely A is going to be same, because A is the ratio of the radius. Ratio of time period. What about B? B is the ratio of the radius. Radius depends on what? Radius in the helical path, right? What is the radius formula? So radius happens due to the perpendicular component of velocity, right? Radius is due to, so radius is mv by qb, mv by qb, but v is the perpendicular component of velocity, which is nothing but v sine theta, v sine theta, right? So here angle theta angle is 30-60 with the field. So that one case it is 30 degree, another case 60 degree. So if you take ratio of radius, which is b, this is ratio of sine theta, 30 degree and 60 degrees. So sine 30 half and sine 60 root 3 by 2. So this is going to give us 1 by root 3. Right. What about C? Ratio of their pitch. So pitch depends on what? Pitch depends on v parallel into time. V parallel is v cos theta into time. So you know that speed is same, right? They have the same speed, right? So time period is also same. So pitch is proportional to cos theta. So what will be C? C is ratio of cos theta. So cos 30 degree root 3 by 2, cos 60 half. So this ratio will become root 3. So now because we know this, now you check A into B into C definitely is 1. So we are getting this. Multiply them, they are getting as 1, right? So any other possibilities are there? Check out. A, B, C less than, no, it is coming 1, right? A, B is equal to C. No, that is not possible, right? Fine. So I hope you are getting this questions. You are getting a feel of solving this basic level of questions. Then gradually we can work out more questions. Thank you for your attention. So let us continue discussing the problems. An ionized gas contains both positive and negative ions. So there is a gas which has both positive and negative ions. Along, if it is subjected simultaneously to an electric field along the positive x direction, and a magnetic field along the positive z direction. So the gas is having a mixture of both the kind of positive and negative ions, and there is electric field applied and magnetic field also applied. Both the fields are applied. Okay. Then what will happen? Positive ion deflect towards y direction and negative ions deflect towards minus y direction. So first of all, try to draw that. Okay, draw these fields. Which directions fields are? So which direction fields are? First we'll draw the field. So electric field is which direction? Positive x direction. Magnetic field is along positive z direction. So electric field is along this direction. That means along x-axis, right? And you know that this is y-axis and this is z-axis, right? So this is x direction, right? This is x direction. Now here they are saying that magnetic field is along z direction. Magnetic field is along z direction, electric field is along this direction. Z directions means it is coming out, right? Okay. So the gas is having ions. Then what happened first of all? What happened first of all? The electric field will accelerate. Yes, the ions. So positive ions, suppose if I take positive ions will first of all accelerate. So it will gain some velocity in this direction, right? And what about negative ions? Negative ions will gain some velocity opposite of electric fields. They may get different velocities. Okay, some acceleration will happen, they will get some velocity. Now magnetic field is in this direction. Now think about it. What will happen? So it will try to rotate, or some deflection will happen, right? It will try to make circular motion. So V cross B direction you find out. V cross B. So this is V and B is coming out. So V cross B is downward. So that means what? That means these positive ions will get a force in this direction. Force will be downward, right, on positive ion, because magnetic field is coming out. So V cross B direction will be downward. So this is the magnetic force on the positive ions, right? And it will try to go in a circular motion. So circular motion, or the deflection that will happen, it is in this xy plane, and it is going to have downward. Okay, what about the negative ions? First of all, find V cross B direction. So V and B is where? B is coming out. So V cross B direction you first find out. V is this way and B is downward. So what is the direction of V cross B? V is coming out. So V cross B direction is upward, right? V cross B direction is upward. But because it is a negative, so it will get force in opposite of V cross B. So here also the force will be downward only. Force will be downward only. It will try to go in this way. So this is trying to going in a circle. In circle means it is not exactly circle, because it is under acceleration along the, this direction. It is under acceleration along that direction. So radius will keep on changing. Radius will not remain constant, right? But the way it will deflect is like this. Okay, so this is, now let us try to choose options. Positive ion deflect towards positive y direction, and negative ion deflect, both are deflecting towards negative y, right? Negative y, they are bending towards negative y. So all ions deflect. We can go with option C. And option D, you see, positive ion deflect toward no. So we can go with option C. All the ions are deflecting towards negative y direction. Clear? Right? Let us move next. Two particles A and B of masses Ma and Mb respectively. So two particles have masses, okay, and having same charge and are moving in a plane. Okay, so they have same charge, same mass. No, masses are different. Okay, masses are different. They have same charge, right? A uniform magnetic field exists perpendicular to this plane. So dot dot, it is, dot means coming out. Okay, the speeds of the particle, speeds are also given. The trajectories are shown in the figure. Trajectories are given here in this diagram. Okay, then they are asking what is, larger, smaller. So let us try to figure out what is possibilities. So first of all, if you see this one, definitely its radius is larger. Radius is larger, and it is going like this way, right? So this is, the radius is larger and this radius is smaller. Okay, first let us take about it. So radius formula, apply radius formula. Radius is equal to mv by qb. QB. So what about the charge, same magnetic field. Okay, and MVs, and then masses are different space. So this radius is large means MV, the product MV must be larger as compared to B, right? Because B has a smaller radius. So definitely you can clearly say that MA into VA must be greater than MV into VB. MB into VB. This we can clearly say. Why? Because the radius of the upper one is larger. A has larger radius, B has a smaller radius, right? So that we can clearly say. That's what, right? MAVA is greater than MVVB. Directly we can say that. Are there any other possibilities? Are there any other possibilities? Because this radius is larger means the product MV is larger. Okay. What about MA less than MB, VA less than VB? Can we say that? Equal? It is not possible. So definitely this is not correct. Equal also not correct. What about the third option? Is it possible? They are saying MA less than MB and VA also less than VB. So if it is like that, then MAVA will become less than MBVB. That is also not possible. Already first we have rejected. So that is the only option, right? Let us move to the next question. A particle having mass m and charge q enters a cylindrical region having uniform magnetic field. like this it is entering in the inward direction. If the particle is deviated by 60 degree as it emerges out of the field, then what is the time spent by it in the field? So what is the time spent in the field? How do we calculate it? It's a good question, and we can try to generalize things. Okay, try to make a generalized result if it is possible. Okay, so how do we calculate here? First of all, let's think very basic. How can we solve this problem? Okay, so they are saying charge is directly entering like this, and it is going to have a deviation of 60 degree, and the region of magnetic field is limited in this cylindrical. It is cylindrical because it's a 3 dimension, but from the front it is looking like a circle, right? So how do you find out, deviation? So deviation, how will you find out? So it may be taking a definitely a circular path, and here let us say that it is going v cross b. If you take, so v this way, magnetic field is v cross b, upward force, so maybe it is, let us say, going like this way. We do not know. Okay, charge is positive, let us take that it is happening like this way. And deviation means what? Deviation means this was the original path, right? This was the original path. So from this path, when you join this one, that when it is exiting here, you have to take a straight line. Okay, so this one, so this angle, that angle is 60 degree they have given. Okay, that angle is 60 degree they have given. Now here note that this when it is entering here, it is directly straight line will be definitely passing through the center. This will be definitely center of the circle. Now the question is when you join here also, when it is going out, here this is going out like this. Now in this, will this line joining also pass through center or not? First thing, we have to think about it. Will it also be going in that way or not? Okay, so think about it. So might be velocity may go here, let us say, because we do not know the arc may go here, let us say. Okay, yeah, so if it is going like that, will it still be in that manner if I try to join it? But definitely when you join this point where it is exiting, and where here when you join, this will be a chord, this will be a chord. Okay, this will be a chord, and let us say that it may be going in different direction, but when you join this point with this, that will also form a straight line, that will be radius. But the question is, the velocity where it is exiting, is that velocity also be coming in the same manner? Yes, think about it. That is the first thing. And if this is the deviation, then how can we calculate the time spent? That means this length of the arc. If you can calculate the length of the arc, because speed is same, what will be the length of this arc? If you can calculate the length of this arc, then we can try to definitely figure out how much will be the time, because time is equal to distance by speed. Suppose this arc length is L, so that time is equal to distance by speed. So how will you calculate the arc length? That is the main thing here. How do you calculate the arc length? Now here it is given that options, if you see it is saying that 2 pi m by qb, 2 pi m by 3 qb, pi m by 3 qb. It depends on the speed of the particle. They are saying it depends on the speed. So I think for such case we need to try to figure out a formula that how much time it will require in terms of this angle. So let us try to derive it. Okay, let us try to derive it. So here, first of all, this cylindrical radius is given in the question or not? Is the cylinder radius of this cylinder is given in the problem or not? How much radius it is? They have not mentioned what is the radius of the cylinder. That's also a big point. They must mention here that information, like what is the radius of this cylinder, isn't it? Isn't it? What is the radius of the cylinder? Emerges out of the field, then what is the time spent by it? What is the radius of the cylinder? Of course, it is 60-degree deviation is happening, but what is the radius of the cylinder? Suppose it is not mentioned radius, then you may nothing is mentioned, then suppose I take this like a joining a center. So that means we need to consider how much will be the arc length. So by some symmetricity you can do its radius will be here in this direction. If you try to think about its radius may be here, and similarly when you join here like this, and if you think like this angle, so what about this angle? So perpendicular here, right? Right, and on this if I consider this as perpendicular, then that means this is also 60 degree. If I consider this angle 60 degree, that means it has rotated 60 degree. So if I simply think in terms of how much angle it has rotated, 60 degrees. So what will be the length of this arc? This length of the arc will be angle 60 degree, you write in radians, and then this radius r, we know this radius. So r into this theta we can write. This r is equal to how much? This r is equal to mv by qb, mv by qb, and this angle theta is pi by 3. Okay, so this is length, and then if I substitute there, I can get time. Time is equal to this divided by speed, then pi m by 3 qb. In one step we can get the answer, but note that this answer which is pi m by 3 qb, that is possibly correct, but definitely here this radius must affect it, because this is a advanced question. There is a similar question pathfinder. Now let us try to assume that it's not necessarily that it has to, because its radius may be different. Okay, so we need to definitely assume that some radius must be there. So let us try to derive it. Okay, very important. Suppose this is a circle, and let us say the magnetic field is spread here. Okay, we do not know how much it is, and assume that charge is positive charge, and let us say that the charge particle is coming like this way, diametrically it is entering, and let us say that it is going like this way, somewhere it is going. Okay, and actual radius of the cylinder you have to assume. So this is the center of this. Okay, center of this, and let us say that this will be the radius capital R. Capital R is different. But if I try to make small r, means definitely if I draw here perpendicular, I need to take, right? I need to draw a perpendicular here, and here also this is part of a circle, so I need to draw perpendicular here. Okay, so these two must match somewhere, so that center will be here. So perpendicular on this might be somewhere here. Okay, so this will be the center of that, somewhere this center will be there. This center, let us say o dash, because this is perpendicular here, here it is perpendicular. This angle, what will be this angle? This angle might be something else. Okay, this angle, let us say this angle as theta, or let us say this angle as alpha. This angle alpha will, and this radius is small r, which we know this radius is mv by qb, right? This charge particle which is going, this speed v, its mass is m, charge is q. Okay, so this radius, small radius, we know this capital radius must be given in the question. Now this is going a circular arc, right? So what is given in the question is the deviation. Now what is meant by deviation here? So suppose if I try to join this one, not that after that it will go into a straight line, but if I join here, this deviation will be this one, and this deviation, because on perpendicular line this one is that, and on this perpendicular line this is there. So on this perpendicular this. Okay, so this angle will be same as alpha, alpha or theta, whatever you want you can take that. Okay, let us keep at as theta only. Let us keep this as theta. So these angles I am keeping this as theta. So this angle will be theta. Okay, right? But if I join this one, suppose if I, definitely I can join this one, right? So this is the arc length. Time spent, if you want to calculate, this is the arc length which we need to think about it. This arc length is, let us say L. This length L I want to calculate. The time is equal to L by P, right? So how do we calculate this length, arc length L? Now we need to think about it. Okay, and this angle is 90 degree, right? This angle is 90 degree here also. This angle is 90. This definitely here is a very key idea here, that this angle is 90 degree. This total angle is not 90 degree, need not be 90, it can be 90. Like in that question which we have solved, we have assumed that, but it is not necessarily. Okay, it is not necessary. So here this total angle need not be, but this angle has to be 90 degree here. I will join it now, this line. Okay, so this has to be 90 degree, this is 90. Now what if I try to join here? Let us see if I join this one, this end. And you know these two triangles will be congruent because this is equal to this r, right? Because these two triangles will be congruent, r, these are properties, right? Those things will be equal, because this, note that this is tangent here, but this is not tangent. When you pass this line, it may become a chord also. Suppose if I extend this line here, this may become a chord, this may become a chord. Very, very important point. This may become a chord, it may not be a tangent, but in this case, this length and this length are equal. So this is r, and this is capital R, and this is a common side. So these two triangles will be congruent. Okay, so I can definitely say that this angle, these angles will be half angle. Yes, this angle will be theta by 2, equal angles, right? Okay, now if I take in this triangle, definitely it's a right triangle. I will highlight that triangle. I'm going to highlight that triangle. This triangle I am taking. Okay, so now if I take in this triangle, this tan theta by 2 I can write as capital R by small r. That is the key. Once it is done, over. So tan theta by 2, is capital R by small r, right? Then from here we can substitute, of course, capital R, small r, we can substitute mv by qb. Okay, we can substitute. So this is tan theta by 2, and from here theta we can calculate. So theta will be 2 times of tan inverse r qb by mv. Okay, once you got the theta, how much the angle is rotated, right? So this angle theta is helping us to calculate this arc length here. So this arc length is small r into theta, small r into theta. So now theta, we know this, we can substitute here. So now the time will come as L. L means r into theta. R is that mv by qb, into this one. Theta means 2 times tan inverse of r qb by mv, right? Divided by speed. Divided by speed means this speed I will remove. So once I remove that speed, I got a formula for time. Time definitely does not depend on speed. This is one thing that we can write. So 2m by qb, 2m by qb, right? 2m by qb, tan inverse r qb by mv. This is the exact formula that we have got it. This formula is a very nice formula because it can help us to understand what is the time spent and how does the speed affect the time. Now very important, suppose if you increase speed, what happens? Let us say some different particles are thrown, similar kind of particles are thrown, let us say same charge, same mass, but speeds are different. If speed is different, suppose speed is higher, if higher speed means this is going to be smaller, and as this becomes smaller, then time will become smaller. So higher the speed, smaller the time spent, and lower the speed, more the time is spent. This is the exact relation. This is not just a inverse relation, this is a tan inverse function, right? So I hope you got this idea, but in this question they must have mentioned what is that radius, otherwise we cannot say that. So in one sense, in true sense, you can say that none of the option can be unless they mention this. But if you assume that, that these distances, no, this is like exactly like a tangent. Okay, if they have mentioned it exactly like a tangent, then and that means both are tangent, then you can definitely apply this and you can say that option will be option C. Option C, in that case you can, if you consider this diagram as correct, okay, or if they might have given this proper diagram. Fine. So I hope you got it. Let us move to the next. Let us move to the next question. Okay, a particle of specific charge is to mass ratio alpha starts moving from origin under the action of an electric field and magnetic field. Its velocity at a particular point is given. The value of x naught is. Try to draw the diagram. Suppose if I consider this diagram as, let us say this is x-axis, this is y-axis, z-axis is coming out. Magnetic field is in which direction? This positive z direction. Electric field is along this direction. So this charged particle will definitely accelerate along the electric field direction, right? It will gain some velocity. X naught, V naught, they are saying that we do not know which direction it will go, whether charge is positive or not. We do not know. So let us say that it is, suppose charge is positive. So velocity this way, V cross B, B is coming out. So V cross B direction will be downward. So initially the magnetic force will be downward. So this particle is going to take a turn like this, and somewhere let us say its coordinate is x naught comma y naught. Z is 0 because it is moving in xy plane only, right? Because force is downward, so it is going to move in this plane only. Now here, what can we apply? We need to calculate x naught. So speed here is given. What is this velocity? They have given 4. So 4 is along this direction. Let us say here velocity is in this direction. So it must be 5, right? Because along x-axis they have given 4, along y-axis downward it has given as 3. These two are the components, right? Okay, so how do we calculate this? So if you go by force analysis, it may be lengthy, but we can always understand that the work done by magnetic force is always 0 because it always acts perpendicular. So we can apply work energy theorem that work is done only due to electric field or electric forces. That work done is change of kinetic energy. Let us apply this. Let us apply this concept. So work done, net work done is change of kinetic energy. Initially it was released means its speed was 0. So change of kinetic energy means half m v square. V is given as 5, so 5 square, right? Initially work done, that's only work done because initially it was speed 0, so change of kind, and work is done only due to electric force. So electric field is acting in this direction, this displacement is x naught, here the displacement is x naught, and electric force is constant, charge into electric field into distance x naught. This is what it is. So 25 m by 2, correct? So from here x naught will calculate as 25 m by 2 q e naught. Q by m is alpha, so 25 by 2 alpha e naught x naught, right? So this is what it is, x naught. X naught comes as 25 by 2. Let us choose option C. We can go with option C. Fine. Let us move to the next problem. A particle of a specific charge q by m is projected from origin in the coordinates with initial velocity. So initial velocity is somewhere along x and y component are there. So x is positive, y is downward. Uniform electric and magnetic field exist in the region along positive y direction. And okay, so along positive y direction both the fields are existing. Okay, let us try this. So suppose I take that this is x-axis and this is y-axis, right? And we are throwing it, particle is being thrown. Which way it is thrown? Which way it is thrown? So let us draw this full, this direction, this direction. Okay, so which direction the particle is projected? It is projected x direction it has velocity u, right, and this direction it has velocity v. Minus means downward direction. Okay, right. Then uniform electric field and magnetic field exist along. So electric field and magnetic field both are in this direction. Electric field as well as magnetic field both are in this direction. So definitely what will happen, this v, the velocity v, which is opposite of y direction, this will under retardation, this will decrease because electric field will try to reduce its speed, right? And this speed initially it will remain as it is. And what is the direction of the magnetic force? So magnetic force will act only on this perpendicular component of velocity, right? And u cross b, if you do, then which direction it will go? It will come out. So the plane of this circle may be like this. Okay, plane of this circle will be xz plane. Xz plane will be the plane of this circle, right? But it is also having a velocity in this direction initially, right? And initially retardation it may happen because field or electric force is opposite. So it may go like, in a circular motion, but it will be going down. So helix may be there, but gradually the pitch may be decreasing. Radius, what about radius? Radius may not decrease. Radius will not decrease, okay, but the pitch may decrease. So somewhere it will stop in this direction, and then again it will go in that reverse direction, right? And then it will move in this way because it is under retardation in this direction. So what is the question here? The path will definitely return to the origin once if, okay, so yes, retardation, as I told, retardation, and it is starting from here. So this part you can draw here, okay, this portion you can consider here. Okay, so the path will be, what type of path it will be? So it will be going like this. Helical motion will be there, but helix may decrease, pitch will decrease. Okay, like this. So once it is stopped, then again it will return backward. Okay, the quotient particle will definitely return to origin once if this is an integer u square u2 plus v2 half be, it's an integer vb, maybe it is u square plus v square by 2. Okay, vb by pi is an integer. Okay, when it will return back, that is what it is showing, when it is returned back. So first of all, the time by which it is taking to revolve in this plane, what is that time? Time period we can calculate. Time period is 2 pi m by qb, right? Time period does not depend on the speed, neither this component of speed nor that component. But what will be the pitch? Pitch. So suppose it goes in one cycle, right? So as it is decreasing, as the speed will decrease, so the speed will also increase in the same way, because in this direction it is having uh, speed, and initially the direction of acceleration this way, right? So pitch will be decreasing. So first of all, try to note this, that what is the acceleration? Acceleration along y-axis we will write as plus qe by m. This is the acceleration. Initial velocity along y-axis is downward, right? And suppose it has to come back at the same point origin. So when can it come back in the same point? And we calculate at what time it will come, right? How will you calculate that time? So displacement along y-axis you can take as 0. So displacement along y-axis is 0. Displacement is downward, velocity downward. So minus like ut plus half it is square plus half acceleration is qb e by m into t square, right? This has to be 0. From here time we can calculate. This time is how much? Calculate this, t1 goes 0 and this 2 mv by qe, right? This is the time. So we got this time. Now question is, this is an integer, u square plus v square half. That means that is speed they are talking about. By b pi e is an integer. Vb by pi is an integer. Ub by pi is an. So this time, let us say this time which they are saying. So note that the time period is the time for one cycle. So suppose it goes some cycle and it stops. Let us say it stops. Then suppose if it stops, then what happens? Let us say if it stops, then what happens? Because in this direction it is going, radius it is going, and then it stops somewhere. And suppose it stops in one complete cycle, then it will be stopping on the, where it will be stopping? It will be stopping on the y-axis, because one complete cycle will happen when this velocity will touch at the y-axis, right? So when it is touching y-axis, then only one complete circle happen. If it is not touching along y-axis, one complete circle, it might be half also will not happen. It will be touching the y, because it is starting on origin, which is a point on the y-axis. Again it will touch the y-axis in one complete cycle, right? Pitch. So of course the pitch is decreasing, but whatever it is, the time it will be for one cycle time will be fixed. So within that time only, so this must be some integral multiple of time period, we can think of that. So let us try to write this time as integral multiple of t. So small t is an integral multiple of capital T. So t by capital T must be some integer. So what it will come, try to take that ratio t, small t by capital T. Small t by capital T is what? Check out that. So small t is 2mv by qe divided by capital T. So that means qb will go up and 2 pi m. How much this comes? Calculate. So 2m gone, q gone. So here become vb, 2m gone, right? So q gone, vb, and here m will be there. Pi also is there. Pi will remain. M is gone. Pi is remain. Pi and e is going to remain here. Yes. Because 2 got cancelled, m got cancelled, q got cancelled, pi and e remain. Now this must be an integer. Let's check out this. Vb by pi is an integer. Vb by pi is an integer. Yes, option C we can match with option C. Very tricky question, right? Then let us move to the next. A particle of mass capital M and charge q moving with velocity we describe circular path of radius capital R when subjected to a uniform transverse magnetic field of direction B. The work done by the field when the particle completes one full circle is. So first tell me, work done by magnetic field is what? There is no electric field here, right? This problem, is there any electric field or any other field? Particle has mass m, charge q with velocity v, describes circular radius r, subjected to magnetic field. So there is no work done by magnetic field. Magnetic field does not do any work. Work done by field when the particle complete one full circle. No work done. So we can directly choose option C. Correct? Let us move to the next question. A block of mass m and charge q is released on a long, smooth, inclined plane where magnetic field B is constant, uniform and horizontal parallel to the surface. So magnetic field is like this way, it is parallel to the inclined surface, right? Uniform, horizontal, okay? Find time from start when the block loses contact with the surface. When the block will lose contact, okay? So what will happen? Try to figure out what happens in this question. So as you release, this body will start falling downward, right? So as it is gaining velocity, suppose magnetic field, so try to draw the free body diagram, then it will be clear. Suppose if I draw the free body diagram, so mg component, you resolve this mg component. This is mg sine theta, you already know that. This is mg cos theta, this is the normal, right? But it has a velocity in this direction, so magnetic field is coming out of this plane, right? Dot. So which direction the magnetic force will be, because it has got some charge. So q v cross b, v cross b direction, if you see, v and b is coming out, v cross b will be this direction. So magnetic force is acting like this way, magnetic force, and v is this way, and magnetic field perpendicular, so magnitude is qvb, qvb, right? The question is, when it comes out means normal becomes 0, almost going to come out. So normal becomes 0 means what? Normal becomes 0 means what? That means this qvb has to balance mg cos theta. qvb has to balance mg cos theta. But note that this velocity, the velocity at that given instant, at that instant. So this velocity we have to calculate time. So this velocity, which is the velocity gain, v equal to u plus at. So in this direction, acceleration was what? Acceleration was g sine theta, right? So v equal to at you can take, so g sine theta into t. So let us use this g sine theta into t. Let us write, so q into g sine theta into t into b is mg cos theta. So from here, what will be the time? Check out. So time here, of course, cot theta may come. Yeah, cot theta is coming. G will get cancelled. G will get cancelled. So m cot theta will come, cos by sine, and qb will be there because g got cancelled. Right. So option C is going to be the correct answer, because this is the right answer. M cot theta by qb. Fine. Let us move to the next. When a proton is released from rest in a gravity-free room, it starts with an initial acceleration a0 towards west. Now this question is gravity-free. There is no gravity here. Okay. Proton is released from rest in a gravity-free room. It starts with an initial acceleration a0 towards west. Okay. So it has some acceleration. When it is projected towards north, with a speed, it moves with an initial acceleration 3 a0 towards west. Electric field and maximum possible magnetic field in the room will be. Now we need to find out what is electric field and magnetic field. Okay, let us try that. Proton is released from rest in a gravity. Suppose I release a proton. Release means its speed is 0. Okay. Then it starts with an initial acceleration a0 towards west. Towards west means this direction. This direction, it gets a force. That means this must be electric force only, because charge is at rest, magnetic force cannot act, electric force is only acting. And acceleration, what is given as a0, this must be charge is plus e, right? So e by m. So electric field now we calculate as m a0 by e. And this electric field, because it's a positive, so electric field is acting in this direction. So this direction, electric field must be there, because acceleration is happening in this direction. Okay, so this electric field is in the direction of west. Definitely we can choose, right? So electric field, first answer is electric field, m a0 by e west. So you can remove this option. Last one also removed. So other options got removed easily, right? So this is the first answer. But let us see about the magnetic field also. Magnetic field, which direction may be acting, because second condition they have given. Okay, when it projects towards north with a speed, suppose you projected in the north. So this is proton and you are projecting it with some speed now. With a speed, it moves with an initial acceleration towards west. Again, the acceleration is towards west. That acceleration is 3 a0. So there must be magnetic force in the same direction. Okay. So now v cross b direction must give the magnetic force. So if this is v direction, which direction b will be there? Think about it. Either inside or outside. Suppose if I take inside cross, so v cross b will give this. Yes. That means inside means what? This is a horizontal plane, right? Inside means forward towards the north direction, towards the north direction. So this direction is uh, which direction it is? Okay, first you calculate also. Um, See, they have given here. That means both the fields are there. Electric field as well as magnetic field is there. So now extra forces is also happening. We cannot directly say that. Definitely both the things will be there, electric force as well as magnetic force, both will be acting in this way. So 3a naught that we are writing is the net acceleration due to electric force plus magnetic force divided by mass, right? And electric field we have already calculated, right? That we have already calculated. Electric field is how much? So charge into E, that is ma naught plus magnetic force, and this become 3 ma naught. So magnetic force is 2 ma naught. Okay. So but magnetic force contribution is that same direction, correct? So 2 ma naught and ma naught, that's what it is, 3 ma naught. Okay, but the thing is that which magnetic force down, which direction it is? Is it downward? Field they are asking, field. Suppose magnetic field is downward, downward or upward means what in this plane? Upward and downward means what? So this is the plane, horizontal plane, right? In horizontal plane, forward backward is like north south, left right is like west east. Okay, so if you apply, let us say in this direction is west, and if you are throwing, which direction is velocity? Okay, it is projected towards north means north means it is the front way, right? North means it is like this direction. So this direction is upward direction and downward direction, that is different direction. You have to properly understand direction. Okay, so I'll give you the direction first. Suppose if I draw the coordinate system, so if I consider x-axis, this is negative x-axis, this is positive y-axis, this is negative y-axis, this is positive z-axis, this is negative z-axis. So if now I write directions here, so this direction is west, this direction is east, this direction is upward is what? No, upward is not north. Front is north, so this is north, this is south, this is upward, and this is downward. Now it is clear. Unless you draw this diagram, things will not be clear. Okay, now you try. So if force is here, a force, magnetic force coming this way means velocity, and velocity they have given this north direction. So V cross B, which direction magnetic field will be there? Suppose if I take magnetic field upward, so V cross B will come this way. Magnetic field you have to take downward, so magnetic field must act downward. Then this V cross B will give us in this direction magnetic force, because charge is positive, right? So definitely magnetic field, now you calculate from here, because magnetic force we have calculated. So QVB is 2 ma naught. So magnetic field now you calculate as 2 ma naught by QV, right? This is what V means, V naught it is. Okay, so this is the magnetic, but it is in downward direction. So now you choose it. So first option itself is correct, we have already done it, but to check this answer, charge is E here. So now we can verify both the options, right? Fine, so this is how you can solve questions. You have to analyze deeply in all the problems. These are all worksheet level 1. So you can see the quality of the questions in level 1. Very high standard qualities are there. If you can solve these worksheets, definitely your fundamental will become very clear. JEE you can easily crack. Advanced also you can be prepared of to some extent, right? So then we'll see in the next one. So let's go for this question. Two particles of charges plus q and minus q are projected from the same point at a velocity v in a region of uniform magnetic field B such that the velocity vector makes an angle theta with the magnetic field. Okay, their masses. So magnetic field it is making theta means helical path. That's all. They are going to move, but their charges are different. What about their masses? Their masses are m and 2m. Their masses are different. Okay. Then they will meet again for the first time at a point whose distance from the point of projection is. So when they will meet again from the point of projection. So let us try to figure out. Suppose if I consider that this is the direction of magnetic field, right? And at this point we are projecting it. So suppose if you project it in this direction with a velocity v, this is let us say plus q, mass is m, right? Mass is m, minus is 2m, okay, minus is 2m. This mass is m. So what direction it will go? You know that this is going to move in a circular path. Again it will come here, then next circle, like that helical path it is happening, and these distances are the pitch. You know that from here to here one circle. So this is one pitch. Let us write pitch as p, then next pitch, right? Let us write this as p1, pitch for the first one. So pitch 1 will be how much? This time period into v in this direction is what? V you need to resolve, that is v cos theta, and v perpendicular is v sin theta, because this angle is theta. So pitch 1 will be how much? Pitch 1 will be how much? Pitch formula is time period for one circle multiplied with this speed. So v cos theta into time period. Time is going to be different. Why? Because time formula remains as, time is different because 2 pi m by qb, right? Here mass is m, but for second particle is shown like that only, but second particle has charge minus q and mass 2m, and it's negative. So charge is negative means direction of force will change. So here magnetic force is which direction? V cross V opposite you have to see. So this is v perpendicular only, v cross b, you see magnetic field is this way. So v cross b that side, but because it is a negative charge, so force will be this way outward. So its plane of motion will be like this. It will be coming out in this plane and it will be going like this, right? So it will be going along this direction only, right? In this direction velocity will not get affected, v cos theta, but only thing is that first it will turn like this, then next turn it will take, right, like this, further next turn like that it will go. But the thing is that what is the pitch here? What will be the pitch for this? Suppose it starts and it comes back here. So this is the pitch for this one. Let us write pitch as pitch 2, pitch 2, pitch 2. So this will be going in like this way. So what about the pitch 2? Pitch 2 calculation. So same v cos theta, but the time period is t2. So v cos theta time period is 2 pi, mass is 2m, mass is 2m by qb. So definitely that this is going to have a larger pitch than this, but double it is, right? Double it is. So you can see the pitch is going to be, I will just draw a rough diagram to understand that. So this particle, first particle is going like this, pitch, this is like pitch 1, pitch 1, okay. But second particle, this pitch 2 is 2 times of pitch 1, note that. So if the second particle, if you are calculating, its pitch will be here to here, this will be pitch 1, sorry, pitch, first time pitch, next time pitch will be like that, it will be coming. So that means they will come again, they will be meeting at this point here. This is the common point where they will meet, right? So that means this much time. So this much time is time period of the second one you have to consider. After how much time it will meet? They will meet after this time. They are asking time or distance. What are they asking? At a point with this distance, they are asking distance means pitch 2 they will meet. Pitch 2 we have already calculated this one. How much this will come? How much this is coming? 4 pi m V cos theta by QB. This is the answer, right? So let us choose the answer. 4 pi m V cos theta by QB. Option D is the correct answer. Fine. I hope you got this question. So let us take up this question. An electron moving with a velocity v1 2I cap at a point in a magnetic field experiences a force F1. So let us try to first draw the diagram. So if there is a electron is moving with a velocity v1 2I cap. So which direction force is acting? Force is acting this direction. F1 vector is minus 2 j cap, right? This information is given. Right. If the electron is moving with a velocity v2 plus 2 j cap, now velocity direction is changing. 2 j cap means upward. So if the electron is going in this direction plus 2 j cap, then what? It experiences force F2 plus 2 I cap. Now the force is F2 is plus 2 I cap. The force the electron would experience if it were moving with now minus 2 k cap velocity is there. So let us say now the velocity is minus 2 k cap. So this is x axis, this is y axis, but it is inside. So third velocity is minus 2 k cap. What is the force now on this? So assume that only magnetic field is present. Assuming only magnetic field is present, then magnetic force only we need to see, and we do not know the field directions. So if you try to just think of field direction, suppose for example, if I say force is this way, so V cross B direction I will choose. So V cross B, suppose if I take field inside, V cross B will come upward, but this force has to be opposite of V cross B, so V cross B should come upward, right? V cross B direction must come upward. Why? Because electron is a negative charge, so V cross B must come upward, force must be opposite of that. So this is correct. So magnetic field is inside. Magnetic field is inside. Can we say that? Magnetic field will be inside means that means minus k cap direction, right? Can we say that? Definitely. Similarly here, suppose magnetic field is inside. Let us say magnetic field is inside. Now check this one. Is it correct? V cross B direction you choose. So V cross B is inside. V cross B direction will give this way. So then magnetic force, yes, this is correct, because here V cross B direction is this way. So opposite of that will be coming, right? Now in this case, what it will be? V cross B. So note that magnetic field is inside. Magnetic field is inside. What is the value of magnetic field? That also calculate. So force is 2, right? Magnitude is 2. V cross B or QVB. Charge is E. Velocity here is 2 into B. So B becomes 1 by E. But in terms of vector, it is minus 1 by E k cap. This is the magnetic field, so simple. So if this is the magnetic field, from this first and second we can verify that. Then now if velocity is given along minus k cap means velocity is parallel to the magnetic field, so no force will be there. So force vector in the third case is going to be 0 vector. That's all. 0 force will be there, that will be the answer. Let us match that. So the answer will be option A. Fine. So I hope this is clear, right? Let us try this question. At time 0, a charge q is at the origin. Suppose there is a charge which is at origin and moving in y direction, so it is going upward with a velocity. Some velocity is given in the question, right? It is moving upward. Then the charge moves in a magnetic field that is directed out of the page for y greater. So upward, above the, that means above this xz plane, that means y greater than 0, field is coming outward, dot. and for downward field is going inside, directed inside. Okay, the charge is subsequent trajectory. This trajectory of the charge. From this information we can deduce that what can we get. So just try to find out the science first. And here radius also we can see, here radius is small, here radius is large. So magnitude wise if you compare, which magnitude will be larger? So we know the radius, suppose this radius is r1, this radius is r1, this radius is r2. So r2 is definitely less than r1. We can clearly see in the diagram. So radius is mv by qb, mv by qb is less than mv by qb. Here magnitude we are comparing, so r1 means r2, r2 means this b2 and this is b1, correct? b1 b2. So from here we can definitely say that b1 is going to be smaller than b2, right? Magnitude wise, note that, because charge may be, charge is what is the charge? Is the charge positive or not? Because see, the charge is positive negative, it may affect it. So but anyway radius we are comparing, so when we are comparing radius, it is the magnitude of this, isn't it? It is the magnitude, because radius means it's the magnitude length, right? So here we are going to just say that b1 magnitude is lesser than b2, correct? b1 should be lesser than b2. Now what about the charge? Now you see here, uh, you see the direction of force. So suppose if you see at the topmost point here, you can see at the topmost point, if you see here the velocity is this way, velocity vector is this way, right? And magnetic field is coming out. So v cross v, and force direction we know, force is directed towards center, force is downward, force is downward. So v cross v direction will be what? V cross v direction will be what? First you calculate, because b is known, outward, v is this way. So v cross b, it is coming downward. Downward means this charge is positive. It is definitely coming from here. What about this case? Also check. Now velocity is this way, velocity this way, and the magnetic field is cross. So v cross v again upward. Yes, this is correct. So charge is positive. We can go for that. Charge is positive, right? And magnetic field 1 is lesser. So option 1, that is the correct answer, right? So I hope you got some basic ideas about solving such problems. Questions are very good level, and definitely if you have got through this, then you will be able to work out many more questions like that. Okay, thank you for your attention.